finish up your extra examples, we're going to look at the next example right here. And the first thing I need you to identify or recognize that you immediately see lines intersecting. And so because you have lines intersecting, therefore you're going to have vertical angles. All right, so since we see line L intersects line L, or line T, excuse me. I'm going to show this again in class. You'll see me write this again. This is a symbol that means therefore. This is when we're kind of making a conclusion. Therefore, we have vertical angles, and I'm going to abbreviate that. So, since you have vertical angles, then you're going to have some type of congruent angles. You got to identify the ones that are congruent. So, I'm hoping that you can look right now and automatically see that angle 1 and angle 3 are your vertical angles. Therefore, they're going to be congruent. So therefore, I can basically say that the measure of angle 1 will be congruent to the measure of angle 3, which is the same thing as saying angle 1 equals angle 3. So now I'm just going to substitute, okay? When we're solving here, our steps are going to remain the same as we did with segments. We first draw and label. So if you weren't identifying or recognizing the angles, we can have the angle 1. I would put this expression in the interior, 5x plus 3, and then angle 3, 7x minus 11. And notice that I kept the same marks because I'm showing that they're congruent. And now I'm just going to substitute for them. So, hope I hit the right one. Angle 1 is our 5x plus 3 is equal to our 7x minus 11. So we're solving for x here. Instead with your smallest variable, which is our 5x. That will cancel out, leaving us 3 equals 2x minus 11. And then add our 11 to both sides. And so you can see that without even doing this. And then we're solving for x. And so we should see that x is 7. So we're going to solve that, box that in. And now they want us to find our answer, our problem here is to find the measure of angle 2. So now I'm just going to come over here and I'm going to have to substitute. Now to get to 2, so I don't have an expression for that, I'm going to have to use 1 or 3. So we're going to start with the measure of angle 1. Since that expression was 5x plus 3, so we're just going to substitute 5 times that 7 plus 3. And so we get that the measure of angle 1 is 38. So I'm going to go ahead and I'm going to put, well, I'm running out of room, but I'm going to put 38 in here. 38, 38. Angle 3 is also 38 because vertical angles are congruent. And then we're going to talk about how to find angle 2. So whenever lines intersect, yes, you have congruent angles with vertical angles, but you also have, and I'm going to see if this helps some of you. Let's add this here. Let's see if it'll let me fill it. No, it won't. Let me pause just a second and fix this. Okay, you don't need this, but maybe folding your paper might, or putting your hand over the section. I did this so I want you to see something. So we have vertical angles formed by formed by lines intersecting. And also, I'm going to use this to kind of cover up a part. So we want to find angle 2, okay? So I'm just going to cover up, let me rotate this a little bit. If I cover up angle 3, I'm hoping you now see that 1 and 2 are a linear pair, okay? So not only do you have vertical angles when lines intersect, you also have linear pairs. You have adjacent angles that are on the line. They're on this line right here at the bottom. I will just kind of denote that. Right here, if I look at this line, like such, 1 and 2 are linear pairs. So they are supplementary. Let me move this out the way. Let me. And let me come up. So since 1 and 2 are supplementary because they're linear pairs, then I can find the measure of angle 2 just simply doing 180 minus 38. because linear pairs equal 180. And so angle 2 is 142. 142. Oops. And this would also, across from it, it's vertical.